Great intro this morning. Thank you. Yes, so we are focusing on recent images taken by the Hubble Space Telescope. These are all from 2024. So these are very recent, hot off the presses. Just to recap, we've looked at the Hubble before, but the Hubble Space Telescope was launched in 1990 on the Space Shuttle Discovery. And since then, Hubble has reinvigorated and reshaped our perception of the cosmos and uncovered a universe of unexpected wonders and images. Let's look at some of those images. This image was taken in March, so just last month, and it shows a globular cluster about 162,000 light years away. It's located in the largest and brightest of the Milky Way's satellite galaxies, the Large Magellanic Cloud. A notable feature of this image is that the globular cluster fills almost the entire image frame. In contrast, there are numerous Hubble pictures that feature entire galaxies that more or less also fill the whole image space. And the reason for this is because the telescope has a fixed field of view. So certain objects will seem larger or smaller based on how near or far it is from the camera lens. And 162,000 light years is quite close, if you can believe it. FS Tau is a multi-star system made up of FS Tau A, the bright star-like object near the middle of the image, and FS Tau B, the bright object to the far right that's obscured by a dark vertical lane of dust. The young objects are surrounded by gently illuminated gas and dust of this stellar nursery. The system is only about 2.8 million years old, very young for a star system. FS Tau B is likely in the process of becoming a T-Tauri star, a type of young variable star that hasn't begun nuclear fusion yet, but is beginning to evolve into a hydrogen-fueled star similar to our sun. This gauzy-looking celestial body is UGC 5829, an irregular galaxy that lies about 30 million light years away. Despite there not being many observations of this relatively faint galaxy, it does have the distinction of having a descriptive nickname, the Spider Galaxy. Perhaps the distorted galactic arms with their glowing, star-forming tips bring to mind the clawed legs of an arachnid. This is an artist's representation of a brown dwarf. This class of object is too large to be a planet, but it's too small to be a star because it cannot sustain nuclear fusion since it's less massive than even the smallest stars. The name brown dwarf is actually a misnomer because the object would typically appear red to the naked eye. A brown dwarf is likely to be marked by these wind-driven horizontal bands of thick clouds that may alternate with relatively cloud-free bands, giving the object a striped appearance, as seen here. This image shows a galaxy about 52 million light years from Earth in the constellation Virgo. The dwarf galaxy is one of many forcing its way through the comparatively dense gas in the Virgo cluster, a massive cluster of galaxies. The pressure exerted by this intergalactic gas is known as ram pressure and has dramatic effects on star formation. Here are Hubble images of Jupiter taken on January 5th and 6th of this year, capturing both sides of the planet. Hubble monitors Jupiter and the other outer solar system planets every year under the Outer Planet Atmospheres Legacy Program. This is because these large worlds are shrouded in clouds and hazes stirred up by violent winds, causing a kaleidoscope of ever-changing weather patterns. We can see storm activity on both sides of the planet and traveling in opposite directions. Here's another galaxy in the Virgo cluster, this one about 55 million light years away. This galaxy appears to have quite an irregular tubular form, so it might be surprising to find out that this is actually a spiral galaxy. If it were viewed face on, it would resemble the shape that we most associate with spiral galaxies, these curving arms sweeping out from a bright center, interspersed with dimmer, darker, less populated regions. But when observing the skies, we're constrained by the relative alignments between Earth and the objects that we're observing. Here's a really interesting headline. Using the Hubble Space Telescope, astronomers observed the smallest exoplanet where water vapor has been detected in its atmosphere. At only approximately twice Earth's diameter, the planet could be an example of potential planets with water-rich atmospheres elsewhere in our galaxy. However, it remains too early to tell whether Hubble measured a small amount of water vapor in the atmosphere or if the planet's atmosphere is mostly made of water. Because the planet is as hot as Venus, around 425 degrees Celsius, it definitely would be an inhospitable, very steamy world if the atmosphere were predominantly water vapor. What we're looking at is called a fast radio burst, or FRB, a fleeting blast of energy that can, for a few milliseconds, outshine an entire galaxy. Hundreds of FRBs have been detected over the past few years. They pop up all over the sky, like camera flashes at a stadium event. But the sources behind these intense bursts of radiation remain uncertain. And this new FRB is particularly weird because it erupted halfway across the universe, making it the farthest and most powerful example detected to date. An international team of astronomers has assembled and reprocessed observations of the exoplanet WASP-121b that were collected with the Hubble Space Telescope in 2016, 2018, and 2019. So this provided them with a unique data set that allowed them not only to analyze the atmosphere of this exoplanet, but also to compare the state of the atmosphere across several years. And they found clear evidence that the observations of WASP-121b were varying in time. The team then used sophisticated modeling techniques to demonstrate that these temporal variations could be explained by weather patterns in the exoplanet's atmosphere. I always enjoy looking at images of the Hubble Space Telescope and learning more about our universe, and I hope you all do too. Thanks, everyone. I'll see you next week.